Okay, we're on the section 18 of the notes and just, kind of read it through. It's a brief lecture. Again, we're hoping you're following along with what we're doing. And I should say it's a brief introduction. It's not going to be a lecture. It's going to be a brief introduction. So what are we doing over here? I'm going to read it to you. All right. So what does it say over here? Alternating series of the form. Well, what's nice about this over here? It's very similar to what you did in Math 120. All right. So you've seen something like this where AN is some term and those terms are greater than zero. They're positive terms. All right. So, what do you get? A1 minus A2, A3 minus A4, yada, yada, yada. I would say when you're given a series, do not assume anything until you write the first few terms down. And when you do that, you should have an idea if you're dealing with an alternating series or maybe a series that might have changing signs, but not alternating. Again, for it to be alternating, it's got to be doing plus minus, plus minus, plus minus, plus minus, plus minus, or minus plus, minus plus, minus plus, minus plus, minus plus, ad infinitum. All right. So, we dealt with this before, particularly with the geometric series, we've seen this before. All right. So next thing up, they got this definition thing going. And they talk about a word that's often is confused or not fully understand, but they say absolutely convergent. So what they do is they look at a series like this, which sometimes can be very difficult. It could be an alternating series. It may not be an alternating series. But what do? They look at the absolute value of the terms. Sometimes this actually simplifies the series a great deal, right? I mean, a great deal. If you can look at the absolute value of a series, you kind of discount all the sign changes in the problem. And again, whether it's alternating or maybe a sign comes into it every now and then, it's nice to be able to do that. And if it is, what we do is we say the original series is absolutely convergent, all right? Conditionally convergent, what does that mean? The series as written convergent, but the absolute value of it doesn't converge. So we would say it's conditionally convergent, all right? So a little theorem over here. If the series is absolutely convergent, then it's convergent, all right? Alternating series test. It's also called the Lyman's test. Let me see if that's written at the bottom of the page, by the way. Yeah, right over here. Okay. It depends where you are in the world, what they call things, but it's pretty easy to go through it. And again, another footnote to read it. Alternating series. Again, remember AN is positive. What do you get over here? You need to show this and you need to show this. If you can show those two things, we're going to say the series converges. All right. There's a problem with 60, by the way. I'll be honest with you. It's not easy to understand. It's important to note. I'm going to write this outline for it. It's important to note that the AST is not used for a test for divergence. It's not. It cannot be used for a test for divergence. So that is, if it fails, you got to move on to something else. All right. So that is, if the series fails to pass the first condition of the test, do not conclude that it's divergent. All right. Don't conclude that. All right. You got to go back to some other basic test. One of the nice basic tests you could do, though, and by the way, this often fails, but that doesn't mean the series is divergent. We have to move on to something else, and you'll see me do that. All right. We're not trying to confuse you. This section here, I want to be honest with you, though. Some of the biggest problems with this section over here are dealing with the inequality and the limit. We have better ways of doing it, right? So I'm going to say the AST is nice if it's a nicely behaving problem. If it's difficult, and you're going to see some really wacky, difficult problems in this section, you're going to say, I'm looking forward to a better test, and we will have a better test. The better test will be in a future section, and it's going to be called the root test. Let me go put that down for you. We'll have a root test. Let's not worry about it yet, but I'm saying don't despair. This is going to be tough, some of these problems, and the other one's going to be ratio tests. Don't despair. We'll have better tests to use for convergence. Someone says it's overwhelming how many tests there are. You're right. We'll also have a summary at some point, but I'm hoping you're following along and you're willing to continue to follow along. Thanks so much.